Welcome. My name is Troy. I'm a long COVID patient turned researcher. I'm making some short videos with a smidge or a tidbit of science related to low-dose transdermal nicotine as a therapeutic in many diseases. Let's go. For this second video, we'll be looking at how nicotine rebalances NAD homeostasis. This is a study done in mice, not in humans. In the abstract, a general overview of what the paper talks about. So first, nicotine is an anti-inflammatory and it's neuroprotective. Right? This study is done on low-dose nicotine used over a long period of time. It affects NAMPT through SIRT1. It reduces glucose hypermetabolism, reduces cognitive decline, it stimulates neurodiogenesis, it inhibits neuroinflammation, it protects against oxidative stress, and reduces telomere shortening. Now, on to some of the details. Next, the authors show how they were doing the tests. They tested mice at 2, 6, and 12 months of age, and they were giving the nicotine from 6 to 12 months of age. So not their whole life, only for aged mice, in order to see the difference, especially if somebody started taking this type of treatment as they get older. And next, authors explain the connection between NAMPT and NAD, that this data correlates in previous studies. And they also mention the fact that nicotine is a secondary metabolite of NAD. So if you're like me, then you probably had to look up what does NAMPT stand for. So NAMPT is the rate-limiting enzyme that is important for NAD. This converts nicotinamide to NMN. So you probably heard of NMN supplementation. And it's responsible for NAD formation in mammals. And in the study, they also mention SIRT1. They're also measuring SIRT1 levels. And SIRT1 is an enzyme that requires NAD for activation. So if there is more SIRT1, then there's more NAD. All right, so nicotine upregulates the SIRT1 NAMPT interaction. So it not only upregulates NAD, but it also increases the different sirtuins, sirtuin1, sirtuin6, and sirtuin7. Next, a figure showing the different SIRT1 levels in different parts of the body. The blue are the control mice at 2, 6, and 12 months. And the green bars here are the mice that were given nicotine in the second half of their life. So the mice given nicotine had higher sirtuin levels in the brain, in the heart, liver, muscles, etc. Okay, so as people get older, they have more and more trouble getting rid of senescent cells. And they also have problems with glucohypermetabolism. Luckily, here in this case, nicotine helps reduce senescence and reduces glucohypermetabolism, even though these are aging mice. This is tested in vitro here in this part of the study, and it's nicotine reverses glycolytic and mito in the microglial cells. So microglial cells are very important for inflammation in the brain, so neuroinflammation. Next, they explain that the energy metabolism dysfunction may be caused by hyperacetylation of NAMPT, and nicotine may stop this hyperacetylation. And then they did some RNA sequencing and showed that there's a broad impact on things like aging and increased neurogenesis. Next of note, they talk about the fact that there were changes that increased BDNF transcription, and then they did some also field tests with mice, and to see how nicotine might affect their learning. And in these tests, they showed that the mice using nicotine had less anxiety and they had better memory. Paper suggests that long-term low-dose nicotine helps with anxiety and cognitive deficits in aged mice. The benefits also could be related to senescence, reduced senescence of cells. So they test the redox state of nicotine mice, and they found that nicotine elevated the total antioxidant capacity of the cells in the mice. Finally, in the discussion section, they showed that with the low dose nicotine, and here low dose is important, they observed that there was a reduction in markers related to cancer in the brain and liver after nicotine administration for 6 months or more. All right, so next of note, I wanted to point out here that the way that they were giving nicotine to the mice was in their drinking water. So it was diluted in their drinking water. So when they were testing for nicotine in the tissues throughout the body, it didn't have very much. It was mostly concentrated in the gastrointestinal tract. Now, why is that important? That is important because we suggest people to use transdermal nicotine patches. That is because with transdermal nicotine patches, the patch goes through the skin into the bloodstream. From the bloodstream, it gets circulated around the system once and then ends up in the gut where it's processed by the liver. So it's not just different from smoking because it only has one component instead of 7,000 components, but it's also different in the way that it enters and it's actually processed by the body. And then, of course, this also has a large effect on the addictive properties of nicotine, which are highly addictive for smoking. But in all of the nicotine patch research over the past decades, there are no cases of people being addicted to nicotine patches. In conclusion, they summarize by saying that nicotine possesses multiple functions in NAD homeostasis to regulate signaling pathways and metabolism involved in senescent cells. They also show that long-term low-dose nicotine consumption enhances NAD salvage pathway and delays systemic aging, thereby providing a supplement strategy of NAD and its precursors. All quite important findings. I hope you find it as interesting as I did. See you in the next one. Believe it or not, I'm human and I can make mistakes. And this smidge or tidbit of science is far from complete. Comment below with your suggestions or corrections. Let the conversation begin. We are stronger together. Take care of yourself, and if you can, take care of someone else. See you soon.